Okay, so let's frame our day together by looking at this question. Must slope always be positive? If we think back about our experience with slope so far, we've noticed that the slope was always positive. There was always a positive relationship between the two variables we were looking at. So if we think, for instance, with the recipe we talked about where you had teaspoons of salt and tablespoons of honey, as one of those increased, so did the other. If one of those decreased, so did the other, right? We're trying to preserve that recipe, so we need to keep those proportional relationships constant. Now, how can we think about slope being negative? It wouldn't really make sense in terms of a recipe. So today we're going to look at possible situations where slope might be negative, and then what would that look like in terms of a graph? But before we do that, let's look back again at what we've done so far. Let's take a look at where we've been and how we've worked with slope up to this point. Working with similar triangles, we calculated the slope of a line using slope triangles and the concept of similarity. We looked at the vertical side of the triangle and the horizontal side of the triangle in a ratio that we called slope, which measures the steepness of the line. But what if we looked at this without thinking about side lengths of a triangle, which should always be positive, by the way, right? You can't have negative side lengths or negative distances. What if we just looked at it as a change in y value over a change in x value? That's really all we were doing with the triangles anyway, right? With this new idea, we can think of motion as directional now. Up would be positive, down would be negative, and so on. Could we now create a line with a negative slope, or could we create a situation where there was a negative slope or rate of change? Wow, look at this, look at this. So if we look at line AB, we can see a move from point A to point B requires us to go right, which we can now think of as positive. Right is positive, and down, which is negative. There you go, a slope of negative 1/2. We did it. Let's take a look now at the combinations for positive slope. For us to have a positive slope based on our new sort of insight here into what slope can mean, we could either rise and run, if we use our terminology of rise and run. A positive rise over a positive run would result in a positive slope, or a negative rise over a negative run would result in a positive slope. So we think about our background and ratios and looking at the numerator and denominator and the signs of those pieces of the fraction, how we can result in a positive fraction, right? So those are the two ways you can have a positive ratio, which is what slope is for us. On the other side of the coin here, we have the negative slope. A negative slope can result from going up, rising upward, and running to the left, if we think about directions, or going down and running to the right. Either one of those combinations would result in a negative slope. Okay, so we see how mathematically we can find negative slopes through motion. Now, the next piece is to think about the context. How can we make a context? How can we make up a math story where negative slope would make sense? So let's review what we just looked at. When calculating slope, going up and right or down and left would result in a positive slope value. Okay, so that type of motion, up and right or down and left, would result in positive slope values. When calculating slope, going up and left or down and right results in a negative slope value. Okay, what we haven't looked at specifically yet is how that would make sense in terms of the units of x and y, in terms of that relationship like we did with teaspoons of salt versus tablespoons of honey. That's what we're going to do next. Next, we're going to make sense of this in the context of a problem where we define x and y to be specific units, like, say, time in seconds and dollars. And then we can see how a negative slope would make sense in that type of situation. Okay, but that's going to be next class. But for today, I want to stop here and just have us take some time and practice what we've learned so far about calculating negative slope. And I'm going to have you work on these 3 problems at your own pace. And when you're done, we'll review and we'll take a look at what you have.